Okay, this seems to work. All right. Forward and back. Okay, perfect. Hey there, everybody. My name is Pete LeVasseur. So I've been working in the automotive industry for maybe 10 years or so, a little bit more. And I wanted to come today to speak with you all about some work that we're doing called Eclipse uProtocol. So this is work that's incubated within the Eclipse SDV framework there, the Eclipse SDV work group. And the idea being that SDV is still somehow a bit of a unclear term, a vague term, I think as was just mentioned. But one of the key things that people need to accomplish is to be able to get applications to communicate, right? How do we get applications on one device to communicate with another? And so uProtocol, we think, can be a good solution for taking what you have today. Maybe that's a service mess. So you have sort of applications scattered and talking in different ways to something like a service mesh. So something where there's kind of a coherent vision around how we get apps to communicate with one another. I have a lot of sort of like block diagrams and things in the talk today. I show a little bit of code, so I don't delve super deep into the technical details, but if you have questions afterwards, sounds like there's a QA section and you can feel free to find me as well. So first, let's talk about, the why. Why are we doing this? So, in a typical sort of vehicle architecture, we have many different devices suited for different needs. Like we may have some sort of mechatronics device, like a brake controller or something. This is on an MCU, maybe using AutoSAR Classic. You have like an ADAS device on an SoC hypervisor, QNX on one side, Linux on the other, some sort of device that's connecting out to the cloud, out to mobile. And then a device that's used for infotainment, UX, stuff like this, where there's a screen, people are touching, they're trying to do some inputs and things and making things happen, where you have maybe QNX and Linux are in the mix, and then some Android apps are built on top of all of this. So very heterogeneous sort of makeup in a typical vehicle. So that's great. So we have all of these stacks and layers there, and want to build apps on top of it. But some of the challenge with this is that these layers and stacks are very different potentially between different devices, and there's different departments and folks that are writing software in different ways for different needs across all of them. So if we take a look at this, though, we can try to start to draw this line, right, between what are the things which are fairly sort of generic, and probably every vehicle needs to do some version of this, which is being able to pipe data from one application to another, from one device to another. What are those things which are fairly generic? We can call those plumbing. And what are the things which are really differentiators, those things which bring business value, those things that will bring some value to the customers that are driving the vehicle. And so we think that really some of this plumbing here is where uProtocol can sort of fit into the picture. So as I was mentioning, one of the challenges is we have all these apps, and we want them to be able to communicate with one another across devices, within the device, out to the cloud, out to mobile. But there's an expectation that you have to sort of buy into what's available, what's already expected to be used. And so if you have some sort of special needs or circumstances, those things may not just be feasible right out of the box. Things may not be able to communicate with one another. So yeah, there's sort of this problem of, okay, I have a bunch of devices, all these plumbing may not talk to one another right out of the box. So that sort of leads us to this this thought process here, that being able to say get a braking command from an ADAS device down to the brake controller to be able to initiate braking, extremely important. We need to be able to stop the vehicle when we need to. but it's very undifferentiated. So every automotive OEM very likely needs to be doing this, right? So there's ADAS systems on many OEMs. They all have brake controllers. But because of that, there's been a lot of reinvention behind closed doors many, many times of how to do this plumbing. So that's where we think it's a good candidate, doing this plumbing in the open source, because this model allows us to collaborate with one another, understand what are the common needs, and be able to really fund it out of like a, you know, kind of a pooling resources approach, right? Contributing engineers and funding towards being able to develop this uProtocol in the open. So, okay, that's maybe the why, but let's talk about what are we doing in actuality. So great, we have all these apps and services, but what do we need to be able to do with them? What are the things that will make it feasible for us to call this a service mesh, a way to be able to communicate? So we really need something that's sort of simple and easy to understand for engineers and developers, right? So the three things that will really kind of enable that are the ability to have a unified addressing scheme, to be able to do subscriptions across different domains, different devices, and not have to worry about how the routing is happening under the hood, but just be able to request things from different devices and apps. So the other piece is we want to build out uProtocol, and we've built out uProtocol in a way that gives it a sense of flexibility. And so you are able to bring your own transport, write your own transport, and be able to plug into this ecosystem, which we think will help sort of the evolution of software and the ability to maintain software in an easier way by decoupling it from sort of proprietary libraries and protocols. And then another key thing is we really want to keep this programming model and software development model of apps built on top of uProtocol simple. We have, as we talked about, different domains within the vehicle, different programming languages used for them. And we really want to be able to have sort of a consistent developer experience across each of them so that folks that are, say, working on an infotainment product are able to transfer over and still be effective working on another product that may be in a different language. So as I had sort of hinted at earlier, there are sort of existing solutions, and depending on how you count them, many existing solutions for how to wire these apps up. But they often come with buying into sort of a certain way of doing things. And I think that what we're trying to do is position Eclipse uProtocol as being kind of more flexible. So being this automotive grade open source service mesh where you can control some of the transport layer characteristics by being able to write your own and plug them into this ecosystem. And we'll go into some of the details about what these things are. So how do we accomplish all of this? How does all of this stitch together? So I'll go into some of the details on sort of these first three items here. Unified addressing, inter-domain message forwarding, and then cross-domain subscription tracking. So one of the key ways that we make it possible to have this sort of flexible service mesh is we have a multi-layered protocol for uProtocol. So we've got layers 1, 2, and 3. And on here, I'll talk about sort of layer 1 and layer 2 a little bit. So the concept here being that layer 1 is this transport layer protocol. So you can see here, for example, in our reference topology that we've implemented, we have Zeno, we've got MQTT, we've got Binder, and we've got some IP. So these are implementations that we have done on top of these protocols, which expose what we would call our uProtocol layer 1 APIs. So which are very simple. It's send, register listener, and unregister listener. So very simple and easy to understand. Once that's implemented, the one time maybe takes 500 to 1,000 lines of code, then those transport implementations can be plugged into other parts of the ecosystem, such as this layer 2 component here called the uStreamer. So we call this our uStreamer. It's the protocol bridging library. So you take a look and you say, okay, I'm on this device, which all of my apps on this device maybe speak Zeno, but I want to be able to communicate down to a brake controller and be able to speak over some IP. And I don't want to have to write my app, which is communicating to the brake controller in a way that's very tightly coupled to, say, some IP, right? You just want to be able to say, okay, I want to send a message to brake. So this uStreamer has this pluggable architecture where we can plug in a some IP transport and plug in a Zeno transport. And then when the app on the ADAS compute says, hey, brake, then the streamer is configured to know how to communicate that down to the brake controller. Another important key piece is cross-domain subscription tracking. So imagine that you have some app that's on like the ADAS compute. It wants to be able to understand maybe for driver attentiveness purposes, okay, is the driver like maybe tapping the screen a lot on the infotainment or something like this? We want to be able to write the app in such a way that on the ADAS compute, we don't have to think a lot about how we're going to get that information out. We just want to be able to say about a service, say like some sort of infotainment service about screen taps, hey, like send me whenever a screen tap is going to occur, and then have the sort of coordination between the layer 2 component, which is the uStreamer, which is doing these translations between the different protocols, and the uSubscription, which is sort of the manager of these subscriptions. And both the uStreamer and the uSubscription are written in such a way as to be sort of this pluggable architecture that they can use any transport. So we're also able to extend to cloud, backend, mobile, whatever. It's through the same reasons. It's because we have this pluggable architecture for these key infra pieces like the streamer and the subscription, where you can use our reference transport that we've chosen, which is MQTT, to talk out to the cloud, or you could use the Zeno one that we have, or you could write your own and still be able to plug in and benefit from the rest of the uProtocol ecosystem. So there's been some industry kind of excitement and about Eclipse uProtocol, to the point that there is what's called a blueprint in the Eclipse SDV that's been started. It's called Service to Signal, and the idea being that we want to be able to show how we can build an open source SDV stack using these projects which exist within uProtocol or within Eclipse SDV. So uProtocol is one component of this, which is the service mesh, BlueChi as the control plane, and then it's not shown on here, but using another Eclipse SDV project for another piece of the stack. So this was approved, I think, as a blueprint maybe a week or two ago. So work has now begun by folks at Bosch and ETAS to really drive this and sort of prove that we can take these building blocks and build it out. So for me, one of the really cool parts of working on uProtocol was when I was joining, was seeing that there was such a big community interest around using Rust with uProtocol, or being able to enable using Rust. And so there was a Rust language implementation, which was written up by folks at Bosch and ETAS. And this was one of the reasons that I said, okay, this is awesome. I want to go join this team. I want to go work on this stuff. And we found a way, I'll show, to be able to bring Rust in where it made sense. So Rust. I'm sure if you've been at the conference, you probably attended a talk or two about Rust. So I won't really belabor all the details, but is it beneficial for automotive? Yes. Memory safety, better async story. Crates are great. Cargo is great. You probably heard more already, so I'll kind of pause there on that. Is Rust ready for automotive? I think so. The Ferrocene Rust toolchain was safety qualified, ISO 26262, safety qualified last year, and I think that there is a strong case to be made for Rust being sort of the future of developing safety critical software. But is it feasible to really flip an entire company or a department to using Rust immediately? Probably not. It may also not be a good idea due to other reasons, maybe technical, maybe non-technical. So what we did is I worked with the project lead and we figured out where in the project does it make the most sense? Where do we get the most bang for our buck if we use Rust? And so the idea was, okay, let's use Rust for some of the critical services that we need, like the uStreamer and the uSubscription. And that way we can still enable other developers to be able to work with uProtocol using Java, using C++ for essentially the client libraries. So I won't show a ton of code here, but I'll just kind of give the flavor of things and why this is useful and handy. So for example, I'd mentioned earlier that this uStreamer, I can use any transport that you've written. So here I'm showing an endpoint and a uStreamer, where the uStreamer takes in an in endpoint and an out endpoint, and that tells us how we forward from the in to the out. And in this case, I want to show the key here really is in the endpoint, you have an authority, which is essentially some ID that describes some logical or physical device. And then you have this transport, which, as I mentioned earlier, transport really just has send, register listener, and unregister listener. So the idea being that you can take any reference transport that we've written, but you could also write your own, and you can then plug them in here to be able to route between any two transports whatsoever that you would like. So this here is, again, just showing a little bit of the setup where you can create these two Arcdyne transports here. So these trait objects, so anything that implements uTransport, and then be able to make endpoints out of them. And then here, showing how we can add a forwarding rule going from the mechatronics endpoint to the host endpoint, and then vice versa. So the key takeaway from this bit here is, and the uSubscription is similar, but the key point to take away from this here is we don't want to have a very closed ecosystem. We want to have a very open ecosystem where we can provide some of the infrastructural pieces, some of the pieces written in a way that we hope you can take uProtocol and use it in your particular configuration. We've implemented some reference transports, but you are welcome to implement your own as well for your particular use case. So next I'll talk about when you can expect to see some of this show up as sort of a fully stitched together thing that you can use. So we are targeting November for an alpha release. This will be including some of the core pieces necessary to be able to showcase the capability of uProtocol. So with the ability to talk between devices, the ability to talk out to the cloud, potentially down into the mechatronics device as well. And you can see some of what we've got here. So there's language libraries for Rust, C++, Java, Python, and there's transports here, some IP, MQTT, Binder, and Zeno. The story around where uProtocol goes from here is a little bit more complicated. uProtocol was spun out of work done at General Motors, so about a year ago, and put into the open source. And so I've worked on it since about January or so of this year. GM decided to do a restructuring in August of this year. So a lot of the folks that worked directly on uProtocol while employed at GM are not working on uProtocol as much anymore because they're seeking other opportunities. So long story short is we need you. We need you to look into this and see if this can fit your use cases, and see if this will help you with sort of changing the mindset to more of a software-based deployment here where it's easier to move apps around and do code reuse. So that QR code there will take you to the Eclipse SDV Get Engaged page. You can see the mailing list. You can see the community calendar. You can check out the Slack instance and look at the uProtocol channel if you want. And then this bit here is just sort of giving kind of an overall view of between the different languages, what's implemented in them. In particular, you can see that there's a lot of Rust stuff there for infrastructural things like the streamer and subscription. We also have a test compatibility kit, which is a great way to make sure that, say, when you write something in C++ to communicate over Zeno, it can still talk and be understood on the other side by the Rust client that's also communicating over Zeno. And there was a great piece that was mentioned by Jane yesterday, I think, about how open source is like not sort of top down, right? It's like folks at the bottom, everybody's just thinking and talking and trying to convince each other what to do and what would be sort of useful and beneficial for the project. So in particular, there was someone in the community, someone who's a contributor and maintainer, thought, okay, I want better traceability. And so they thought, okay, what can I do? What's a project that I can use for this? And they ended up finding OpenFastTrace and said, okay, I can annotate my words that are in my spec and then annotate my code and be able to show the traceability from some requirement down to software implementation. So this was a really exciting thing for us. We knew we wanted to do it, but he had gone out and found some solution for it and just suggested it, and it fit the bill. So we went ahead and said, yeah, let's do it. So that was really great. That was one of the powers of open source. Yeah, so I wanted to say thank you for the time. I'm Pete. I have a Rust consultancy called Oxidation Partners, and you can check out my blog via that QR code there if you want. You can read a little bit more about what I've done on Eclipse uProtocol, how I've used Rust to implement the streamer and one of the transports. And yeah, it'd be great if you folks could take a look at that and see if there's anything interesting. Also, big shout out to Daniel Krippner. Put together a lot of the material for the slides, and I sort of took them and remixed them. So I wanted to give a shout out to him and a big thanks. All right. Thanks, everybody.
Pete.